Hello everyone, welcome to another stream. How are we all doing? How's it going? Hey there Ransel, hey there Zaka. Um, yeah, so I'm not sure we're going to get to the rendering it exactly, but we're working on the core engine right now. Part of it, but we're just getting the essentials we need, right? So I'll hop over to the Discord and we'll grab the to-do list back up. Yeah, so last stream we did a hash table. Previous stream before that we did a dynamic array. And today we're working on an object pool. So it's one of my favorite structures in programming. So where's the to-do list I did? Here it is. So we did the virtual memory thing, did these two, we're doing this one today. Then we've got keyboard and gamepad input. So I want to build like just the essentials so we can just write. When we do our R&D work, we're not going back into the engine and doing stuff, right? So we'll be getting hot code reloading working after that, custom UI, and then we'll be getting to the graphics R&D. So that's the sort of to-do list from here. Quite high level though. So object pool is specifically for everything. So entities, widgets, anything where we have one type that we want so loads of, and we want checking. So we'll go over exactly what the object pool is. Right. Yeah, so, our game still just looks like this, right? Nothing's changed, we're just doing core engine stuff for now. So we'll be opening up the core, and we'll be adding a new section. But actually, I've got one or two things I want to correct from last stream, actually. And then we'll describe what this object pool is. So last stream got a bit of a thing that I missed. In the initialize, for the hash table, the align of needs to be we shouldn't really care about the entry align, is that right? No, we should care about it. Yes, I think the alignment. So we want to align to a cache line. Have we got a cache line align? That's good. We'll do that. So the reason is because our hashes in our hash table are the size of they are ordered in. Our hashes are put into groups, and those groups are cache line size each, and we should really align it. So if we get up the thing, this was a new drawing. Oh, it is that one. Where is it? With the buckets, this is it. So our hashes are set into buckets, right? And there's like 8 in a bucket. And the idea is if we start reading from the first one, we want to be reading from the start of a cache line. So to do that, we align our whole allocation to a cache line, and that way the first bucket starts on a cache line and it's the size of a cache line, so the next bucket starts on a cache line. And that should help with the speed of things. Alright, so that was the only fix I wanted to do for last stream. There we go. Okay. So this stream working on an object pool. So why am I on an object pool? The word object sounds really insane. It sounds like a OOP type of thing, but it's not that. It's not related to that at all. So, it's kind of common that you might have like an entity structure or something, or like maybe if it's to do with graphics, you might have like a buffer or something like that as an example. And you basically want many objects of the same type. many instances of the same type. So you can either choose to allocate it and have just an array of them, right? Or you can choose to basically allocate each element individually with like malloc or something. But that's obviously not going to be good because they're going to be dotted all over the place in memory. If you have an array, some of the elements will be freed and some will not be freed. So imagine you have like maybe just like a name. Let's just put a name field in here or something like that. So you can either choose to go down the approach of having these stored in one big flat array, right? Or you can go down the approach of every time you want a new entity, you allocate an element using malloc and it's somewhere in memory. Then you allocate another element as somewhere in memory and you just have pointers to these things, right? And if you allocate an array, you might be like, you have to do your own sort of like, you have to do your own sort of checking, like, you know, say if I try and allocate an entity and we go, right, okay, these are all free slots and we'll take up this one. And then I allocate a new one, we'll take up this slot. But then I want to free this one. So then when I free it, the slot becomes available and I have to do some form of like bookkeeping, right? So if I had a pointer pointing to this element in here, and then I try and use it again afterwards, there becomes a problem where you basically, you have a use after free, right? You've freed the memory. So this is what the object pool solves. It's basically the array method of when you have like an array of entities, but you have some additional checking alongside it to ensure that when you free something, a little number gets increased and you can compare your number with the one you have. And if it's different, then you've got use after free. So this is it at its core, basically. It's just like this. So rather than having like a smart pointer, you basically have like a smart index where you have an index that uses maybe 20 bits and then the rest of the bits go to the number that has the counter in it. So it's pretty amazing. So yeah, if people don't really understand that, feel free to ask some questions around it. So we're just going to design an API and go over, well, have the initial data structure and the API, and then we'll implement the whole thing. Yeah, smart pointer. Yeah, smart putter. Yeah, so we just, so we're going to use this in a lot of places. It's really handy. Oh, and the added benefit of this is that this index and generation can be serialized, right? It means you can save out to disk and load it back in and put all of your objects in the right place. And whereas a pointer cannot be. So I want to link you to like where I sort of learned the blog post that I read. Yeah, so this was the original thing I read back in 2018, right? So I'll drop this in the chat. Hey there, Vassandro, how you doing? So basically, it goes over like why using like a handle, or in our case, it's going to be called an ID. Why is it better than a pointer? And yeah, you'll be able to read this take on it. So this is what I read, and then I implemented my own thing, and I ended up calling it an object pool because I could have just called it a pool, but then it would have been, yeah, I don't know. I buggered it. There we go. Okay. So basically, we need a data pointer. Okay. Now, let's first go over like, so we have this sort of like core ID define. Now maybe that's not what I want to do. Maybe I want to call it like call define ID. Maybe you want to change it the other way around. Thank you so much for the follow. I appreciate it. Yeah, so basically you have an ID. It's 32 bits in size. This is another benefit compared to pointers. It's just 32 bits instead. And so it means that when you have a lot of these next to each other, it should be a lot. There'll be a lot. They'll use less memory and also probably be in cache more, right? So basically, you have your pointer to your data, which is the array where your entities live, right? As an example, so it points to the state where the entities live. So the counter needs to be stored somewhere. Hey there, Hoverster. It's been a bit. How you been? Out of curiosity, have you tried C alternatives such as Zig or Odin? If so, what's your take? If not, why not? Yeah, that's cool. No worries. Yeah, it's a quite delicious beer. It's Coca-Cola Cherry. These things made me ill like last week, but I'm back on them, so woohoo. So just a quick take, really. C is good enough. These new languages like to pretend they're here to replace C, but really they're here to replace C++. C is rough around the edges. C isn't perfect. There is a there's a subset of C which could be made into a new language with some improvements on top. But I don't feel like someone has got that yet. You know, I tried Rust for about 4 years, from 0.8 to 1.34. You know, at first I did have that sort of like, oh, Rust is really cool and everything sort of vibe that most people have when they first try out. But then that sort of started, you know, as it got better, the borrow checker just really got in the way, and it just really got in the way of progress. Zig and Odin, Giant, all of that. Some of them have got some decent things going about them, but at the end of the day, they're still beta software, right? They've got some ideas that have not been tried and tested, and sometimes it's just adding more complications sometimes. What I feel like is we need to just, there's something could do less things, But yeah, that's about it. That's my take. Yeah, all power to people using all those new languages, especially when you're new and coming down to the low level of things. If you come from like Python or JavaScript and it's helped you get to the low level things, that's really cool. But yeah, that's all. Then you have to remember that Rust is driving the idea of avoiding security vulnerabilities for the web, not overall program productivity. Yeah, but then the operating systems could do that, right? Like, Rust is making every single programmer solve that problem and not really have the ability to fully solve it. Whereas if the operating systems, which is just 3 of them, right, just did the security, like isolating applications so they couldn't go and do naughty things, then you wouldn't have every programmer having to not do that, right? And plus, the unsafe keyword is there so people can have fun and basically commit crimes. So, but yeah. How tempting is it when you have a keyword called unsafe? You just want to get right in there and use it, But yeah. That was a joke. Sure, the OSs have security flaws, but the OS wished to fix their security flaw. and then they can provide a safe layer. And then there you go. You don't need every single programmer to try and make safe code instead, right? Well, yeah, well, my take isn't the fact that every single programmer does the same thing and the OS already does it. My point is like we have, like, the OS could be doing it, but they don't do it. Right? They can have like a containerized environment by default, basically. And I'm not talking about like flat packs and all of that crap. I'm talking about like proper containerization done in a way which doesn't like hinder the experience like it does on Linux. It's so bad. Most code, I agree, it doesn't touch the deal, but anyone who... Well, perhaps Davros, right? Maybe the OS could be written in Rust, right? Imagine that. OS written in Rust. They do a proper good containerization job, right? And it's provably safe, except for those unsafe areas where they have to wrap it around, right? And maybe they, right, and isolate those bits down. And then the rest of the applications can be written in anything, right? Because you've written a nice, safe operating system with isolated programs which don't have access to the whole machine. That would be something that could happen, right? But yeah. Right, so the object pool. Basically, it's a Super 7 array. We've got a pointer to the data. What I want to do is have a pointer to the counter. So we'll do U16. So should we call it generations? So we'll call this entries. Entry generations. And then we probably want to have a bit set as well, I reckon. Like, because if we want to iterate over these elements and they've got holes in it, we could use the generation counter to sort of tell maybe if we store an extra bit in there. But I think I want to compile this thing out at debug time. So we never use the generation counter. Sorry, a release builds. We never use the generation counter. It's there as just a checker, a debug check for use after freeze, right? We don't want that in a release build. So I think what we want to do is have some form of lovely entry is allocated bit set, right? So we need to probably get some bit set code over as well, because that'd be useful. What other things do we need? We need the number of objects that we have, right? The count, and we have the capacity of objects that we have, right? I think that's about it. That'd be amazing. So there's our void object pool. Oh yeah. Now, oh, that core offset of needs to move. I remember we did that. We did our own offset of because the standard offset of had limitations, which was really weird. So we just did our own, right? Where I just casted null and took the address. Because we couldn't do it if the... I forgot what the reason was. Oh yeah, if the type was made up on the spot, you can do it. Yeah, that was it. Right, so we're just going to grab these from the hash table. Oh yeah. Object pool. I love this data structure. But in most scenarios, rewrites are not always successful. Sometimes introduce more critical problems than were before. Yeah, that's true, especially if you don't understand the problem, right? Well, I also agree. I wish the OS could handle more security. Not a fan of this trend of sandboxing everything in the browser. Two issues there: hackability and isolation between applications. Yeah. See, I think if you was to take the Unix desktop and containerize it, it ends up really bad, doesn't it? Right? Like the kind of attempts of like Flatpak and that, right? But like there is probably a good design out there, I reckon. Because like where you could set up communication between applications still, that the user has to verify. See, the problem with Flatpak, really dumb. I remember I had the Brave, not Flatpak, Snaps. I had the Brave browser in a Snap, and I wanted to download something to an external hard drive. And then I tried to do it. It couldn't see my external hard drive because it's in one of those Snap containers. And then I couldn't even change the container without like repackaging it. I can change the permissions as a user, as the person who owned the machine, to change the permissions. Like it was really bad. So I basically installed the real thing on my machine. But yeah, I think there's a way for it to be done properly. But the biggest thing on Linux is that it doesn't seem. Wait a minute. Yeah, the biggest thing on the how to do it on Linux, on like, they basically replicate the system in a small container. It's really weird. Like the whole system in a small container. It's a bit weird. Maybe there's another way to do that. I don't know. Yeah, snaps are the worst. Right. So we're going to replicate this. Now we want to take this generations out in debug mode, right? If not defined, no. If core debug assertions, and okay, so we don't have debug assertions enabled. I see a problem. Right. 2 seconds. So if these are enabled, we define ourselves a core object pool generations entry generations field. This is a mouthful, but we like mouthfuls, right? There we go. Then we simply just don't define it. And the reason why I have to do it like this is because we have this macro that like generates us a type safe type, right? So, that's all right. Ta-da! Anyway, so we take this. Cool. Oh yeah. Isn't that good? So now we can declare our own data structure. So what we're going to do is we can get a nice API in of all the things we're going to implement today. So we're going to have the ability to allocate individual elements from this object pool, which should be super fast. Then we want to obviously deallocate as well. We want to be able to allocate at a certain place, meaning we can support serialization. So you'll be able to serialize and deserialize. So save it as disk, load it back up to disk, and the pointers that you have or your IDs that you have, your handles, will stay will stay legal, right? You don't have to patch your pointers or your handles. So I could put the ID in here, and then we could generate maybe some type safe functions, but let's just write the functions first. So, right, let's start off with the lovely object pool initialize. So the object pool initialize, oh wait a minute, the whole point, the reason why I did a union is because we wanted to put a structure in it and then mirror the unsafe version. Alrighty, looking good. So we want to have the core object pool void. So here's your object pool. Then we want to take in some form of allocator. Then we want to take in what is the capacity. Then I think we just need how big is an entry. Awesome. Yeah, an entry size and an entry alignment. Maybe an alignment? Right, that should be. So there is our lovely initialize. dInit is simply just we need the allocator in, right? And then just the object pool as well. Nice. Now we want a way to allocate a single element. So this is going to allocate us an object. So we return a void pointer, and we can optionally return you an ID back. You can choose to ignore the ID getting returned, maybe, because you can always turn the pointer back into an ID. Or maybe no, maybe we just have a couple of out pointers. So maybe we say, well, no, you might no. Yeah, we return. What's a good way of saying it? So I might have another ID type where this is like just a core ID void or something like that. Like a void version of it or something like that. Or we could just pass in a U32, right? Like a raw ID. Okay. We'll think about that. So you have your ID that gets returned out. When you allocate. So you get your pointer so you can fill it in, right? But you primarily access it. So we can do a get, right? So you get with the ID, so there's your raw ID. And you get your pointer back to your element. And then we also want to dealloc as well, which is basically like the get, I would imagine. Where you throw in the ID. Oh, why did I delete the get? Okay. Get alloc. We also need a way to allocate at a certain location. So you might choose. So you give it the ID. So this would mean I've saved this out, right? I've saved this one out, and I'm going to then do many people use Linux other than programmers as programmers? Maybe. Maybe. I don't know. Maybe there's some like movie studios that use Linux, right? I'm sure there's some like there's some proprietary software that runs on some Linux, like because it is a free and very flexible OS, right? So I'm sure there's something like that that exists. Hey there, sorry, not name so dark here. Onit Gurano, welcome. Up till now, I've seen you work on shaders and Vulkan, but I've not understood what type of game you're going to be making with all of this. So, we don't know what game we're making just yet. I want to get an initial sort of core engine together for this game. We're just going to be writing what we need to get to the point where we can do some R&D without having to be like, hang on a minute, I need to go and work on some more engine stuff. Like I don't want any of that to happen. So we're just gonna put together this very slim core engine. So I'm just getting so we can just like rapidly prototype. So you know we're only on day 13 right now, and we've already got like a GPU backend. So we can do graphics. We can print out to the terminal from the GPU. There's like everything's just in place from that GPU side of things. So we're just working on some core sort of data structure stuff that will allow us just to go flying basically. And then we're going to do some keyboard input and some gamepad input as well, so get that plugged in. A little custom UI, hot code reloading, and then we'll be doing some graphics R&D, finding an art style. And when I have this art style, then I'm going to think, okay, what game do we want to make, right? So that's the basic idea of how this is going to go. So it will be a little bit until we want to, yeah, we'll you know, we are moving at a good pace. We're in a good pace. What does R&D mean? Research and development. So we'll be doing some research into some graphics stuff. That's sort of not with traditional triangles and stuff, right? My game and engine, to be fair, is still probably 90% engine, 10% game. Yeah. Yep. We want to try and just do stuff, the essential stuff that we need, pretty much. I know I'm going to be needing these. Why don't you use Visual Studio Code? I'm sure it shares all the same key bindings. Not really. You have your modal input in Vim, basically. Plus, I'm not like a Gen Z. I'm borderline. All right. Basically, I'm borderline Gen Z, borderline millennial. So sometimes I'm Gen Z, sometimes I'm millennial. It just depends. And I'm not Gen Z enough to be Visual Studio Code person. You know what I mean? Yes, we can allocate at a certain place. If it's already allocated, it's gonna crash the computer and probably set it on fire. We also want some iterate functions, right? We want a super nice way to say iterate next, please, right? Which is going to give us back a pointer. Oh, give us back a putter. And it returns back out to us some form of C. It would be nice if we had multiple return arguments because we really need this. Oh, no. No, we don't. This ID gets mutated. I got this. Ha. There we go. Because it needs to come in as input to tell us where we were. Okay. And then iterate previous, right? Backwards and forwards, please. What else do we want from one of these guys? I think this is basically it, right? So you can get an element, allocate, deallocate, iterate. Yeah, it's looking pretty good. All right. So now we should really try and figure out our, we're still missing some extra bits because these are the void versions, right? So we need some extra special things in there. So we need like the entry size basically, so we can iterate over like a void range of a void type, of memory. So allocate. Yeah, I think that's what we need. Have that one as well. Bam. Right. So now we need to figure out our. So the thing is, an ID is just an integer in this case, right? And it would be decent if these were just type safe, right? Now, because otherwise you can just pass in any ID of any type, and that would be really bad. So perhaps the best thing to just do is just do a bit of code gen. We're not going to be having tons of different pools of different types. If we are, most we'll have is like less than 10, right? So maybe doing this is probably okay. So we're just basically emulating C++ templates here. We don't necessarily need it for these two, so we can do that same behavior we did for the stack. Our stack is a really good, it fits this style really well because we can just do it for the whole thing. But unfortunately for this, it's just not, it's going to be like the hash table. It needs some good type safety. It's a bit of a problem, but it's okay. Cap. So we'll just be doing address of object pool. Then you use the void object pool. Yep. Allocator for me, please. Capacity for me, please. Size of object pool entries, right? So we get the size of that type. Got to do a dereference. There we go. And then we want the align of. So to do that, we can use our type of thing. So align of, type of, because align of doesn't support expression for some reason. Don't know why they never did that. It's really annoying. dinit, just de-initialize the allocator dinit. So we don't. So we can have like. So we don't have to, make some inline functions for these at least. So there's less code being copied and pasted, hopefully. Size of, line of. Oh, we need those. Okay, now for the rest of these, and I mean literally for the rest of them, we'll do a type safe thing for these, right? So should we get recorded in a nice little macro? Stack, inline. And basically we're just gonna call or return And then I reckon what we can do is we can delete 1, delete 2, delete 3, because they all have 3 or more. Yep. Then we go down, 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 start there. Right, so it's 5 of those, please. There we go, do that. Oh no, I bugged it up. Oh well. I was about to say do that in Visual Studio, but anyway. Maybe not. Okay, so now we've got to do the special thing and like paste this T on the end, right? Yeah, I use type def instead of define. There's practically no difference. The difference is, like, as a user, there's practically no difference. It will show up in the debugger if you use type def, though. Because define is done at the preprocessor level, whereas type def is done at the language level. Which means you need to think, hey, you need to write code. You need to think when you don't know. That's what thinking is for, right? Like, whenever you need to think, it's because you don't know. So if you need to think when you're using Vim, that's because you don't know how to use Vim. It's that simple. So we need to get these return types right. No, they're all right. They're all good. Yeah. So with this get, was it the get or the alloc? Yeah, with the alloc, do we want to? Do I want to create a special type that just returns both of them in some way? Or do you want to have the ability to ignore this, but sometimes ignore that? Yeah. We'll just leave it like this, and we'll get a feel for how it is, because it's just an API, right? We can just change it. Okay. So now we just got to do some things where, let's get these errors all out of the way. Let's get it snug in with the macro. So there we go. We wanted something this ugly. No worries. Okay. Yeah, let's delete these extra lines actually. Rightio. Looking good. So the next thing to do is we need to make sure that these are actually type safe, right? Because what's the point of copying it in? So these are ID, we replace it with the ID, okay? Like that, yeah? Then this void is actually T, right? So anything with void star is T star. Beautiful. So now we just need to say id.raw. This one needs to be address of it, something like that. Right, id.raw, id.raw, raw. Then this needs to be casted into double pointer void, right? And then same with this one down here, because that's iterate next and iterate previous. So that's how we'll go from the typed versions to the untyped versions. Yeah. Yeah, keep using nano there, Ransel. So this is all in a good place now. All right, so now we can get going, actually implementing this thing and do some proper programming. The data structure is ready. The interface is ready. Now time to go ham. Did we change anything with the API? We didn't, did we? Oh, that's it. All this entry size goes. Because what is entry size? It's just T, right? Size of T. So, size of the cup of tea, you know? Speaking of cup of tea, should I go and get one? There we go. Okay. Good. Alright. Now it's time to go ham. And get our super lovely object pool going. So good. It's my favorite data structure. We're going to be plugging in our GPU system to use this right away. Yeah, that's actually one thing we've got to do after we've got this final one in, is translate all, because we've just like we've either dynamically allocated or just used regular C arrays throughout the code base that we've written so far. So something that we kind of want to do. Let's just go to the internal here. See, we just got arrays of 32, right? We just gotta replace those with like object pools or dynamic arrays, right? So yeah, something we'll be doing soon. Getting that all in, be good. Because we've just like really just cut corners there. And also use our custom allocators as well. Hey there, Rohan, how you doing? Good to see you. How's things going? Oh, Notepad. Oh, Notepad is like the worst because the undo the undo is so bad on Notepad. It's really bad. If someone made anything in Notepad, props to them. Yeah, Paul is really good because the problem with smart pointers. So yeah, remember that blog post I shared? Go read that. Where is it? This one. Handles and pointers. Go read this. This is one that convinced me all those years back. In 2018. There's so many added benefits over smart pointers. Because a smart pointer is isolating the problem to like, or is making the problem per object, whereas this makes the problem per group of objects, right? And you have a centralized system. So the only issue is, though, is if you have this thing across multiple threads, you have to make sure that you either lock the pool when you allocate or deallocate so only one thread can allocate at a time or deallocate, but the stuff in it will be safe, right? So the objects can be used across multiple threads, no problem. It's just when you decide to mutate the pool itself, you got to lock it. But yeah, you can like serialize all this data out, load it back in. Incredible. Like you end up doing this sort of thing anyway. It's a very common pattern for me. You always refer to things via ID indices, so this just makes it extra safe. So right, how are we going to allocate these things? We've got entries. We've got entries, entry, and generations, right? Should we align it to a cache line again? Yeah, so let's do that thing where we added up all those things, right? So we're gonna get the size, and the size is gonna be equal to capacity times entry size plus. So we'll put it in, brackets here to make it easy for people to read who don't really know the precedence. And then we want to say size of U64 times entry size. Well, that is for the all right, maybe not. So this is for the bit set. So this would be something like, we're going to divide round up, isn't it? So you're dividing this by, wait a minute. Capacity times that's it. That's the thing I was looking for. So you have this capacity, you divide that by 64 rounded up, right? And you times that by the size of U64. So that gets you the number of bytes you need for a bit set where each bit represents an entry in the array. So we're going to be using this to iterate, but also check if something is allocated or not, that sort of thing. Then we want to do, then if we're in debug mode, we will debug assertions. We want to do this entry generations, right? Where we keep track of like a little counter to tell whether or not you've freed that. Every time you free a slot, you up the counter, right? You up the number. Yeah. I might call it counter. I just like the name counter. I'm not a fan of this word. You know what? Nah, let's keep it. It describes it better. So, much better. So if we have debug assertions, we need to allocate this field. So they're U16s, right? So they're cap. So they're a U16 per entry. Hey there, Wajilla. Hello, Jim Mega. How you guys doing? It's a bit of a catch up. I came from database engineering domain. Awesome. That's one area I don't know much about is databases. It would be, it could be a fun endeavor to do it one day. If I had the chance. As a little side thing, right? There we do all kinds of pools in C++ for efficient GC operations as page handling is crucial in databases. Yeah. So yeah, nice. Yeah. Like a pool allocator in general is like is a good approach for certain problems, right? But this is making it more like associated to a type. Yeah. Yeah, the counter counter. Yeah. I was leaning against my chest today. Damn, that hurts. Oh. Yeah, you should stop doing that. How are you leaning on your chest today when you're programming? Yeah. Unless you're at the gym where you're just doing that sort of like we got that plate against your chest and you're like maybe not. That one's really weird because you gotta lean forward and grab the handles. Right, so we then want to up the size there, but we haven't done any round up alignments, right? So the interesting thing is this whole thing, let's just align this whole allocation to a cache line, right? That way, it's going to be fine. Yeah, it will all just slot together, right? Because this one is no need to round up any alignment here as it is ordered by so this one would be like the entries, object pool entries. This one is object pool blah 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 blah. This one is entry generations. So as each array. Okay, no need to round up as each array is placed in order with the highest alignment first and lowest last. That'll be good enough to explain. So basically when we do our allocation, so let's go to that's the one we want to know. Core alloc, allocator, size, cache line aligned, right? So we've got the data now. So now we divvy out yeah, we divvy out where this stuff needs to go. So the bit set is going to start. So bit set offset size, and then here we'll say generations offset. Okay, so we'll keep those around, and then what we can do is we can then actually initialize everything here. So entries is equal to data, right? Entries allocated bit set is going to be equal to the offset, right? Applied to data, which would be bit set offset, right? And then if we're in debug mode, okay, we're going to go ahead and then entry generations, yep, and this will be generation offset, yep. Now we just set everything else up, like count equal 0, and then cap equal cap, yeah. And that is basically it. We don't need an entry align anymore. Did we need an entry align for the hash table anymore? Did we remove that? No, we still use it. Oh yeah, because it comes after the hashes. Yeah, I think that makes sense. Right. That's amazing. So there's the initialize, now into the deinit. So the deinit obviously just does the calculation. It just does the inverse, right? Oh, no. So it still does the calculation. This time, use the one that's in the object pool for the capacity. Then what we need to do is deinit, right? Get rid of the little return thingy. So this will be, so the pointer goes in here, so it'll be object pool entries, like that. Now we simply just clear everything to null. And then we set that all to 0 as well, just to be nice. Oh. Oh yeah. Right, so now we're on these guys, which is the get, the alloc, initialize, sorry, iterate.
It's right. Oh.
Right, has that fixed it? Yeah. Every time. I kick the cable. I get excited, you see.
Oh.
Alright. Has happened again? Get too excited. And for some reason that fixes it. Okay, it's a bit of a catch up. You found a site called Planet Scale, interesting, to host a database. Fair play. I've never heard it. I've never really, yeah. I remember doing databases when I had some other jobs, but we don't use databases much anymore. So I'm not doing like server-based jobs now, which is good. But yeah, that world's really different. I tried to use SQLite last month, and the errors were like really bad when your SQL is wrong, and I was like, how do people like say this is good software? Like they say you should use SQLite instead of just saving stuff to a file, but then I got a bit of SQL wrong, and it was like impossible to find out if you didn't know how to. You weren't too familiar with SQL. But the errors were like really bad just for when it parsed the SQL file. Yeah, that's bad. Yeah, maybe I could select device to rely on the default mic. Maybe, yeah. Maybe that might work. Yeah, I'll try that next time. No, I'll try it now. Let's try it. But then, yeah, because sometimes it'll feed my mic into it, isn't it? So if I knock that. There we go. And then that should come back in. The desktop audio doesn't come back in though, and I have to. Okay. Linux. But don't worry. I've had similar issues on Windows, just different issues. It's computers. Right. So, what are we going to be doing when you do a get? So all this is just like a superset of an array. Okay. So we have a nice little debug thing where we say, okay, if you have any, oh, wait. So we need some constants. So we're going to define core object pool ID. We probably want like the index mask, then we want like an index shift, then we want a counter mask and a counter shift. Or generation, right? Generation, mask, generation, shift. So we just split it into two, right? Right. So it's you could have two fields, but it's just better when things are just packed into one integer, right? Because the compiler's just like that more. So here we go. So let's chuck the index at the start. So the mask is going to be, we don't really need a shift. So the mask is going to be, let's do the generation one first. So this will go in the high bits. Should we have 20 bits for index and 12? So, interesting. So in the past, I've made it so you can have some user bits, right? So the user can pass in their own custom bits for these things. But I think we will skip it for now until we actually need it, because we might not need it for this project. So let's just ignore that thought. So that takes a full 8 bits. Should we take 12 bits, right? Which means we need to shift by 20, right? Because that'll be, yeah. So 32, take 12, right? It's 20, and that's how much you need to shift by to get it back to the beginning again. And then, so wait, 2 bytes, 3, 4 bytes. There we go. And then that's the other mask, right? So now when we want to get the generation from the ID, so we just want to get the generation, it would just be ID and with this, and then we just shift it out. Now, you don't actually need the mask because obviously it's at the end. So we'll just do a shift for now. And then, obviously the compiler could have probably sorted that out for us, but this will do. So there we go. So now we want to go into the generation. Now, okay, all of this memory is going to be zeroed by default. That's another thing to keep note of. All memory is zeroed by default when it comes to the pool, including when you allocate and deallocate. Where are these pools stored? In any scope as needed? So yeah, we're going to be storing it. Like currently, I have global variables. I'm not sure how that'd be like long term, depending on how we choose to architect things. But currently, we've just got a global GPU variable where it just has all of our stuff in it, and all of our resources. So resource means a buffer or a texture. We're just having a pool of resources, right? And we just use the pool to allocate and deallocate resources, right? That we want. So it's up to you where you want to stick it, but yeah, you need to stick it in some place where, like, where it's accessible basically by the code that needs to allocate and deallocate stuff, and needs to have a long enough lifetime. So all of your objects that are allocated with it don't just get freed all of a sudden. So with the generations, we want to use we also want to fish out the index. So I'm just going to use the word index, full-on index rather than IDX, because it's one letter off ID, and that is not, it's not too good. I like to have at least a couple of letters difference. So, I could have called it a raw ID, and that could have, but that's okay. Maybe I call it a raw ID, and then we can call some an index. Okay. Right. Index. Now we've got generation, and we're doing our little assertion here, and we're going to set that this is equal to generation, and if it isn't, you say use after free detected. We want to say like this is probably going to go into some shared function somewhere actually, but attempting to access object index this with counter or with generation this. But we are currently on generation. But we have generation. But the current generation is, I'll do it. So you want to pass in the index. So index the current generation. So it's that. Then it's generation. Oh no, the access and generation is that one. Awesome. So we'll have to put this in a shared function somewhere because when you allocate, it's going to be wanting to do this sort of check. But let's just write that out the get first. So then the get is literally just going to return the address of object pool. Well, okay. It's a void pointer. So we've got to do our little pointer add trick. So entries, we're going to add index multiplied by entry size. And there you go. So in release mode, right, we're literally just going to be, it probably does an and. Yeah, it'll do like an and then it will basically just do like an array index. That's all it ends up doing. So yeah, there's not much, it's just an array basically. Now to allocate, so we're going to be using our bit set here. I think, can we go into the HCC compiler that I've got? Do we have like a handy bit set function somewhere? Right, we'll just make one. So, well, we want to make some like a function that will help us just work with bit sets, number utilities. Just stick it in here. Static inline. Bit set. So like core bit set. So we want like a bit set is set where we take in the bits of the bit set, and we want to refer to it via some form of like bit index, right? And we also want to have the ability to set and then unset. So oh, you initialize them with zeros every time. Yeah, the custom allocators will do that. But when we allocate, we'll mem set it. When we allocate from the pool, we'll mem set it quickly before. Cool. So I think we want to say like bit set. So bit index divided by 60. Is that right? Yeah, divided by 64. And then you want to say and one shift left bit index modded 64. Now you can obviously replace those with you know, this with a shift right 6, and you replace this with a with an and. But should we do it anyway? Let's do it. But it makes it far less readable, you see. Is that right? Think so. Not that one. Get out of here with those intrinsic stocks. So shift right by 6, that'll get you. So you're going from. So imagine you have like 65. You shift right by 6. Obviously get you 1. Good. Whereas if you do like 55, bam, 0. Perfect. So that'll land you in the correct word. Right. In a bit, Russell. But then like, so you got like 5. Well, 5 isn't it? That's not good. Right. I knew that one was wrong. It felt wrong to me. So you're. Oh, right. I was being dumb. 63. And it was 63, right? So. Yeah, 63 is all those bits. So you're getting the bottom bits. Yeah. That'll be it. You could have modded it with 64, but then you can just AND it with 63. Bam. Right, so that'll get you whether or not. So you want to return a boolean here, right? And then you know, you can then just cast it into a ball like that. Let's just be explicit about it. And there you go. So that is set. We also want like a set. So can you set a bit for me, please? So it's basically the same thing. You just or it like that. Void. And then unset is unset will be. Oh, I don't have a return. Get out of there with the return. Then to unset a bit, you're basically anding the not of this, right? So if you not this, it'll be every bit except for the one you've set on, and then you're anding it to say keep those guys, right? And voila. There we go. So now we've got this super lovely convenience functions. These can help us with our bit set. So the basic idea is when we allocate, if we got this is it. When we allocate, if we have debug assertions on, we want to do this. No, we don't. If we got debug assertions on, what do we want to check? We want to say if this bit is set, then it's already allocated. So we want to say core assert. So I guess it can just be a debug assert. Debug assert if the object pool is allocate bit set. Wait a minute. Oh, no, 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 no. We just need to find... We need to find the next free bit, isn't it? So here we can use, like... I've not done it with a bit set in the past. I just decided to do the bit set. In the past, I do like a linked list. So you can like just basically take the head of the list and then point to the next one. But then I think with this, the reason why I wanted to try it with a bit set is you could basically solve the problem of having too many holes in the array, and you can allocate them from the front to from front to back. So I think the method we want to do here, let's delete a lot. Let's just delete all this. I think the method that we want to do is so we can do a nice easy check to say we should probably have a count to say, you know, how many free and inside this you know what, we can still do a linked list. We just have to ensure that our entry size can hold a pointer. Yeah, we'll do that. So we'll do like a free list head. Yep. So we'll hold a free list so we get fast allocations. Yeah, I like that. That's good. Okay, so let's make sure we zero our free list head for a minute. Free list head. Oh yeah. So we also need to assert that our core assert that our entry size is greater than or equal to size of pointer. Entry must be at least the size of a pointer so we can store the free list in its place while it's dead, right? Awesome. So what do we need to do here then when we allocate? So first of all, we check the free list, right? So the free list head, if that's available, we've got ourselves an entry right away, and we can literally just return that. We just got to get the indices and all that, right? Demonstrate. Thank you for the follow. Welcome, welcome. So the idea is you just do a bit of maths, right? You take the 2 pointers away from each other. Ooh. Pointer difference to take from. And then what we're going to be doing, so then we need to divide it by the entry size. So there's a bit of a cost here. So hopefully this function gets maybe inlined. We'll see how small we can make it. And hopefully you can just inline it all. And then entry size will be a compile time constant, because it's just size of the element, right? But anyway, then this divide can get sort of optimized into like a shift or something, hopefully. But anyway, so now we've got the index. Then in debug mode, we need to fish out the generation. So I think the job of this if statement is like, get us the index, right? And then what we need to do is we need to make U32 generation. And then we need to end up making an ID of some kind. So we're going to say dereference ID out equal index here. And then here we're going to return, wait a minute, pointer to the data. That will be, let's get that ready. That'll be what we return. So it'll be core pointer add. Okay. Then we're going to be adding to the entry pointer, and we're going to be adding that new index. Now we should really do that before this, because what I want to do is mutate that index. I want to OR on generation, shift left, whatever that generation shift is, right? And then here I want to do a nice little memset on our entry, because part of what I want to, like, when I have these things called objects, right? 0 is initialization, it's the default. Like, I'm going to architect these data structures so 0 is the default. So yeah, we'll just be mem setting it. There could probably be some more intelligent mem setting, like maybe like when we allocate it, we can be like, oh, is there anything that's neighboring, right? So maybe like to do, is it better to also memset neighboring elements? Yeah, but then you have to know. Isn't it? Like, am I 0? Is this one 0? That takes a bit of. Yeah, maybe that's just okay. If you're uncertain about your passions and interests, how do you explore them to discover them? I don't know. You seem like you're quite passionate about programming, right? Like, or are you trying to find like a subsection that you're trying to be passionate? So the first thing is like, you try and find the most easiest way you can get access to trying out this interest, which is not spending a lot of money and not spending a lot of time. You try and minimize those two things, because those things are quite, you basically need money and time in life. So the less you spend on it trying to discover, just to find out an answer, the better, right? But yeah, just give things a go. Have a little project, have a little aim, something you want to achieve, and set a little limit on the amount of time you want to spend and money, and just do that and give things a go. And it's not a waste of time if you decide, this is not for me. Or maybe you come back again and be like, I've got a different perspective and I want to try that again. But yeah, try and see if you can like solve the. Try and see if if this test for your way of this thing, this passion is something you're really interested in. Make sure when you try it out, you really test it enough to see if it is something you really actually like, and you achieve that goal before you quit. There's no program before completely free. Yeah, there's tons of good resources online, right? Also, if you just speak to people, they'll help point you to the right resources as well. How do you identify the core principles and values that should guide your decision-making process? The core principles and values. Difficult question. You just gotta. You got to figure out what you want to achieve, what you want to do, what problem you're trying to solve. You got to see how other people have solved the problem. You have to try things out in a very cost-efficient way, as in don't spend a lot of time. Yeah, just try things out, test it out. Sometimes things are hard, and you have to get your hands dirty. So that's basically it right there, which is good. What I want to say then is the index, if you haven't got a free list entry. Oh, wait a minute. We nearly buggered something up. Guess where the free list head is now? Right here. So in a dereference, avoid star. Wait a minute. Wrong way around. That is equal to pointer. Cast the void pointer into a void star. Dereference it, get the pointer that's stored at just the 8. You're just pulling 8 bytes from where this pointer is pointing to. That's all you're doing. I'm putting it in the free list head. So the next one is like, well, I've ran out of I don't have a free list head set, so I haven't freed any elements, right? So what we do here is we simply do a debug assertion, and we say, okay, object pool count is less than object pool capacity. And if that's not true, object pool of this many items entries is now full. So you would just say, what's ZDU, isn't it? So you would then say object pool capacity, bam. Now what we need to do is then you get the index with this one, so index equal that, and then you say this plus equal 1, and then you fetch this guy with that. Memset, 0 that memory for us, get the generation counter, all that on in debug. Yeah, but you might save it out to disk. But if you save it out to disk, do you want a generation counter? This is maybe questionable. I think we can remove it. Sweet. So that's the allocation done from what I can tell. Oh no, we need to set the is allocated bit set bit. So we need to use that super lovely core bit set. We then use the object pool bits, and then the bit we're going to be setting is the one in index, right? So we then set index. There you go. U32 for the index, right? Because it's got to match this. Cool. So that's the allocation done. Very nice and minimal. Super nice. Yeah, I was thinking that, Joe Mega, that's a good point. It does seem ugly robotic. We're not bothering with thread safe code at the moment, no. Yeah, I'm still figuring out what I want to do about that, but because until we make the game, I don't think it's a problem worth solving yet. But you know, I was thinking like, yeah, Yeah, because I probably, because there's that talk by there's that talk by. I was watching this talk recently, again. Like I watched it before in the past. Destiny 2015 multi-threaded. I don't know, something like that. Wait, it's a 2015 one. This one, and they basically like use a, I wouldn't copy this system exactly, but they use like a. Let's drop it in here. It's an interesting talk. Basically, they use a they have like a job system, and they don't use like they mark which job uses like reads and writes to certain resources, and they'll like provably make it thread safe that way instead of using like locks like mutexes and things, and then you can scale it across multiple threads and things. It's interesting approach. But yeah, it's well off because I want to do some R&D first and actually find a game and do just do like the essential engine architecting, right? Yeah, lock free. Yeah, so you're just scheduling work to happen making it wait, like the job wait rather than and your threads are just job threads in the end. What is the allocated bit set tracking? It's tracking allocations. So we'll be able to iterate over the empty slots very easily. We can go from the start to the end, basically. So rather than having a linked list, rather than having like a linked list, which will sort of point to the allocated elements and things like this, right? And jump over them when we iterate. We're going to be having a bit set where we just have like bits representing what is set or not, and we can just go over this bit set and then only go in to the entity or whatever the memory here for this element if it's actually set or not, basically, and keep the access linear. So if there's allocations that are if there's two allocations that are allocated together, your linked list could be done in a very poor way. It could like start there, it can go all the way over there, and then go there, go somewhere over here, somewhere else, and then finally go back to there. And it could be really bad with the bad access patterns. So we want to this is allocated bit set as a way that we can iterate over the object pool in a very hopefully efficient way. Although we have got this free list, which means we could have lots of holes in it, which is a problem. The bit set is as large as the pool. It's got enough bits to represent the it's just got enough bits to represent the every element in the pool. Recently saw there's a Microsoft research to make a weak counter of a reference counter pointer weight free. Right, so that like like in Rust, it's got that arc thing, isn't it? That atomic reference counter thing. There's a way to make that lock free or weight free. What? So what about using atomics? Because can't you just decrement the pointer and then just if you're the last one, you free it, right? Is that right? So to allocate at a certain place, we just want to do the assertion that this thing is not set. So debug assert. debug assertion that this thing is not set. So I need to get the object pool entry at index blah is already allocated. Nice. So after that, you can get the pointer for it. Get the pointer for it, zero it. Okay. Yeah, zero it. Well, maybe we don't care about it being zeroed, because if you're allocating an element at that pointer, if you're allocating an element at that point, like, nah, maybe zero it. No, we'll zero it. So anyway, we set the bit set. We then want to get the generation counter for it. No. We might want to compare the generation counters, right? Or maybe you store your generation counter in there. There's no point doing a check, I don't think. Let's try that. I think that's a good idea. Famous last words. I think that's a good idea. So yeah, we'll say when you explicitly allocate a certain place, you get to define the allocation. Or why don't we just pass in an index at this point? No, because you might have serialized it with the ID and generation. Yeah. Okay. Yeah, so you'll set up the generation and then we just return the pointer out. Excellent. Very cool. So the next one we want to do is deallocate. So to deallocate this, you just want to basically... Okay, is there a free list thing in here? Because if you allocate a certain place, it's going to have a free list entry, which means something is going to point to you and you're going to point to it. Yeah, we've got to solve this problem. Let's just quickly do the deallocate first so we can see it more. But the issue should be revealed a bit more. So we need to do we kind of just need this. Check here. Attempting to use our free detected. So we want to just say, like, you know, this thing has already been freed. Attempting to free object generation. Okay, we want to say like double free detected. Okay. Then what you want to do is you want to increment this by 1. So you up the generation by 1, and this is how these things can come out of sync, right? Because you've maybe allocated a handle and it's been, or like an ID, it's been copied around everywhere, but then you free it, and if you try and use one of those copied handles or IDs, you can then just, this is where it becomes out of sync, right? So now we need to unset. We also need to make sure that it is allocated. So is not allocated, right? Attempting to deallocate object pool entry that is not allocated. Fantastic. Then we get the counter checking. Oh yeah. Wow, I did a little voice thingy. I was like, what is that? Thank you so much, VMT. Appreciate it. Thank you for the Ko-Fi subs. Yeah. Nice one. See, you should check out the Discord now, get access to the code, have a bit of a play. Thank you, thank you. Lock free or no locks, wait free is no atomics. Oh, wait free is also no atomics. Weird. Nice, nice. Thank you, thank you. Evening, evening. For thread safe, you need to isolate page lists for each thread. This is achievable with singleton handling the allocation. Right. Atomics aren't wait free because the CPU still needs to do cache flushes. Yeah. Okay, my mistake. Wait free is no compare and exchange. Okay, so they're probably doing something with ads and subs or something. No, but that's a uses compare and exchange underneath sometimes. Oh, it doesn't have to. It can have compare and exchange, but not compare and exchange loop, right? Fair play. But yeah, how's it going, VMT? How you been? We're writing my favorite data structure, the object pool. It's basically a Super 7 array. It's my favorite thing. Use it everywhere. Why don't we use the entry size? Oh, yeah. Right, so we need to store. Now we need to store the free list head into here. So we do dereference of a casted double pointer, right? Of the pointer, store in the free list head. Okay, free list head could be null or could be set to something else. Store in there, bam. And then we want to say this is equal to, or the free list head is equal to this pointer, right? There you go. So that helps us get fast allocations is this free list. And we just essentially store the point. But we have got a problem with this allocate at though, with the free list, because we just basically overwrite the data in there and don't patch up the free list. So we'll have to look into that. All my days are dangerous. Did I just catch that? Sometimes we've done this and not done times. Entry size. Oh, that'd have been fun. Okay, so I guess let's just complete these two and then we'll fix the problem. And then we'll see if we can solve this free list thing more elegantly. I don't know. We'll see. So I'm planning with the iterate to basically find us. So maybe we'll have some more bit set things. I want to have a way in this bit set to like basically, I'll just do it in line. I don't care. So what do we want to do here? So the problem is, so the thing I haven't mentioned, right, is 0 is null, right? When it comes to our IDs, absolute 0 is null. Where is it? Here. So this means that if you have a generation counter of 0 and your index is 0, that means that you've given out a null ID. So I think what we could do to solve this problem is every time we allocate, we up the generation instead of when we deallocate. Right? That's one way of solving it. Another way of solving it is just doing it specifically for the first item. And another way of doing it is adding and taking one from the index when it comes to, you know, when we access. Yeah, I think we might do it that way. So I think when we store it in there, we just add one. Yeah, because that way then 0 is, yeah. So we always, because they're in the low bits, right? So it's fine. The generation counter's in the high bits. So adding one will be safe. So whenever we extract out the index, right, we just take one. Okay. Except for if it's null though, you don't want it to be. Yeah, so you want to set it's not a null ID. But they could have a null. But if you do this approach, we are going to do it with the counter instead. The reason is because this is only with debug assertions anyway. So we can just put if statements in here and it's not a big deal. So we can just say, okay, if generate, so we just say like if generation so I think we'll up the generation in here. Up the generation here, get the generation. So get the generation, up it, store it back in. If generation equals 0, add another one, right? It's not the best, but okay. Just avoid having a 0 generation. So what we want to assert here is, first of all, we want to assert that you don't pass in a null ID. So core debug assert ID cannot allocate the null ID. Another one would be so when you deallocate, so when you get as well, it's another one. Cannot access object using the null ID. This one down here in the deallocate is cannot deallocate an object using the null ID. Yeah, so I'll do this little thing here. You know, you could just mod it. No, we're not mod it. No. Ignore me there. So this one just gets it, stores it in there. This one. Awesome. Cool. Right, so to do these next ones, what I want to say is like the ID here, if it is null, will give you the first one. We'll start the index off at 0. Anyway, got to think about that. Yeah, I got a big glass bowl. I got a couple of these, so I like to drink water from these. Yeah. So I go through tons of these a day, basically. They got like a liter in it, maybe more. Yeah, they're about a liter. Hmm. Beautiful. I don't know, I've already answered questions today about Odin and whatever. I'm fine. I don't want to start another language discussion. But yeah, I program in C for reasons. Put it that way. Yeah, it is. It does very much look like Jai. It does, doesn't it? Some syntaxes. Especially, it's got like some ideas from it as well, like the context pointer that gets implicitly passed around and things like that. So right. So when we iterate over all the objects, the idea is if you pass in a null ID, you start on the first one. Then what we're going to be doing is we're going to be saying, yeah, we always want to give you back the current ID that you're iterating, right? So I think we will have a special thing where we'll say dereference, we'll get the ID out. ID equals dereference ID, right? If it's equal to null, okay, if it's not equal to null, else, okay. Fish out so if it's got an entry already, so we've just been looking at something, we want to basically iterate over that bit set and find the next free element, right? So yeah, this is gonna be a bit of fun. So basically we have a bit set. So we can find out so it's 64-bit words, and we effectively just need to find the word that we're in. Okay, so I'm just gonna say like word index. So the word index is ID or index divided by 64, right? That will land you in the word. So you want to make sure you increment this by 1 because you're iterating to the next entry. Then you want to land your word in the bit set, and now we can use the magic of bitwise operations to check. So if you've got a bunch of bits and you need to find which bit is set and you want to exclude everything before, right? So if you're a bit, you want to make like a mask, isn't it? So you want to say like clear mask. So you want to clear out any. So imagine you've got right. Let's get the calculator up. So imagine you have like all these bits set or whatever. Say it's like a 32-bit one. It could be a 64-bit one, but let's just say it's 32. And say if you're a bit index, it's kind of like, okay. Say if like you've just iterated over this element 9, right? So you up it 1 to 10, and you need to make a mask you need to basically make a mask that clears all these bits out down here in the bit set. So basically you just do a 1 shift left onto 10. It gets you 10 minus 1. Right, so you've just iterated over 9. You've upped it. So you need to get what's known as some form of like, you want to get some like some bit index, I guess. Relative bit index, which is index mod 64, right? And then so that would be from 0 to 63 inclusively. You're on bit 10 now, right? So you want to get all of. So we can either set all of the bits on and shift it around a couple, shift it back and forth, basically, just to clear the bits. Or you can do a 1 shift left 10. Oh, that's in hex though, isn't it? 1 shift left 10. Land you there, take away 1. Gets you all those bits set on, then you knot the output. Right? Then you knot it. And then you and your bit set with this mask. And then that'll give you all of the bits. But yeah, I think it might be easier just to do a couple of shifts. So I think what we can do is we can say set all bits on, right? So that'll just be like U64 max, right? Then you basically just say, hey, shift left by the relative bit index to clear the lower bits out. Then shift right to clear, shift left to then put it back in the right place. And that will get you that mask we just had. Right, that will get you, where's the knot? It'll get you this mask, right? Because you just shifted them out, shift it back into the right place. And then we can use that clear mask when we access our bit set. So our bit set will be a word index. So we get our word out. And what we need to do is we need to and it with the clear mask. Okay. And now we just need to find the least set bit. So to do that, we can use you basically use like count leading zeros or trailing zeros, but we've got it in this nice little function here, which is super nice. So this finds us the least set bit, and we can then use this to get the index. So then we just need to find, so it'll be word index, so what's the easiest way? So this will get us like the offset into the word. So essentially now the next index is going to be, is it word index times by 64 plus this? There's no other way of doing it, right? Because you could be index, clear the lower bits out, then multiply or whatever it is. But yeah, we might as well just multiply it by 64. It's just as good because it'd just be a shift that way anyway. Plus that. Now we've got the next index in the iteration. I think there's still problems with this. We've got to work it out. But this is basically the idea. And then we'll fish out the generation counter. So like you would when you do an at this one. Fish out your generation. If in debug mode. Oh my days. Right. So if we're in debug mode, we want to fish out the generation counter, all that onto the index, and then we can now give that back to the user who's called iterate next. And then we can get the pointer. Thank you so much for the follow. I appreciate it. Welcome, welcome. And we want to object pool entries index. Oh, multiply. I forgot that again. Element size. Entry size. There we go, there we go, there we go, there we go. And then we want to obviously give them back the pointer as well to their element. And there you go. So that's the basic idea. It's probably going to be a bit wrong, so we're going to fix that out. Like what happens if it gets filled up? You've got to like iterate over a bit more, because if it's not got anything in there, like if there's no words, if word equals 0, right, as in there's nothing in there, we kind of need to go to the next word, right? So there's stuff like that to sort out. But anyway, we'll just finish this off down here. So if there's no... Okay, if it's equal to null, right, or core ID null, we're going to start... okay, let's do some of this. It's more likely than... There we go. Jobs are good. Right, now I just got to sort the rest of it out. And obviously the previous just works in a very similar way, but just takes away, I reckon. Oh, undefined behavior, yeah. Yeah. The thing is, like, Rust is a good replacement for C++, but I don't think it's a good replacement for C, though. So yeah, if you're a C++ person, Rust is probably pretty good. By Chris Latnery, the man himself, Mr. LLVM. Nice, so take a look. I do love me some good bit packing. (64-bit). Oh, did you do the thing that Sebastian Alton did, where you've sort of packed all of your... Oh, no, you haven't done it. Oh, you've just done it for the stencil, the state. So the depth. I can't say it. So tired. But I know you mean in the pipeline state, like one of the things you've done it for. It's called 64 bits. Yeah, that is the way. That's the way I'd do it. That's good. You're on this. Yeah. That's the word. Thank you. Yeah, it's pretty good way of doing it. Because to be honest, it's just going to be a bunch of enums anyway, and balls. So it's just better if it's like that. Because computers don't really like. Yeah. It's just better when you just pass it around as a single integer, you know. Right. So what is bad about this? The bad bit is you kind of want to like repeat this here. So I guess, okay, watch me do this do while loop, and guarantee you the do while loop doesn't end up being a do while loop. It always happens, always. You always are like, hey, this is what we need to do, is a do while loop, and then like you always refactor do while loops away. It's a bit like ternary operators, always. And because we sadly still have PSOs, we have hash and cache, which is faster for the hash part. You can just, yeah, definitely. Yeah, but do you think VK shader object is really good? Like, pipeline state object is like, you know, not all hardware works the same, and pipeline state objects like as a way of, you know, certain state needs to be compiled into the shader, whereas some other state can be more dynamic on some other platforms. And shader object just basically undoes a lot of work that has already been done for pipeline state objects. Do people really have problems with pipelines that are not Unreal? Like, is that a real big problem? Like, you know, I think people do like those high shader permutation counts, though, isn't it? And that's what pipelines are really bad for. So I think this is pretty decent, right? Is this good? So we get the current ID. Bear in mind, and if you pass in a 0 ID, null, we'll start from the first element. If not, you get the ID, up it by 1. Now, if the index is equal to, okay, it needs to return a boolean. Okay. So if the index is equal to object pool, is capacity a good idea? Yeah, capacity. Then we've reached the end. So we just return false. And you kind of want to say if it's greater than or equal to the cap, right? Because these could have passed in something silly. Yes. Kronos basically said PSOs were a mistake. And just look at all the companies that contribute to the extension NVIDIA. Yeah, but then again, but what is hardware support like it nowadays, right? Because Kronos keep doing this. They keep saying like they keep coming out like on their blog post and saying, "Oh, there's this new amazing extension," and then you see how many devices that actually support it, and then like 6 months later, and it's basically like terrible. And like if you take a look at shader object. Okay, it's 2.7 of all Vulkan devices ever, right? Not really good metric nowadays, but there's only 2 pages, there's 77 entries, and they're all NVIDIA cards that actually support it. And then if you take a look at like, the layer they've done, it's like, well, they've just done a, like, when this extension came out, people were like, finally, I can now learn Vulkan. And then it's like, if pipeline state object was your problem, you know, it's like you've got bigger problems in Vulkan than pipeline state objects. Like pipeline state objects are like far more simple to work with. There's so many more other things in Vulkan which is harder than pipeline state objects. And they shipped a layer to sort of do all the work for you if this extension doesn't exist. But it's just a hash table. Like I don't, and like it's literally just a hash table. I don't understand. So like, yeah, I don't understand this extension at all, basically. And take the stab at there. Take the stab as HVs and IHVs choose the implementations such as limitations today are encouraged to consider incorporating changes. These limitations of future hardware roadmaps. Right. I don't know. They just keep doing really silly things. Like they've just made Vulkan more complicated now. Like they in an effort of making it more simple, they made it more complicated. You know, I hope they come and deprecate a lot of stuff at some point and do a Vulkan 2. NVIDIA GPUs are basically dynamic state under the hood as far as I know. AMD is basically the same too. Yeah, I guess it's for mobile chips, right? Mobile has been the death of Vulkan. Initial design, right? The problem with Vulkan is that they basically tried to do a desktop renderer and a mobile renderer with the same API, when really it would have been better if it was just a separate thing, right? If they had a Vulkan desktop, like immediate mode GPU Vulkan and tile-based renderer, like that would have been like you know, because API is just really bad because it's got to support mobile. Imagine the tiling API they could have had instead of subpasses. Yeah, I guess, but oh yeah, kinda. Yeah. But obviously, like OpenGL ES is still yeah, kind of like that. Right, I think this is decent. Should we take one more lap over it? Return false. Wait, we didn't return true at the bottom. Skips to end. Right, so you got the word and the word index because we use it later. So what we're doing here is we're trying to find. So we should really probably put. This is like alien code. So we probably put a comment above here. So we're just basically saying like, you know, find the group. You know, you can definitely SIMD this later, right? To do SIMD. So you can do it with SIMD, be much better. Right, find the group of U64s. Find the group of bits. Find the single U64 bit set word we are in. And do, you know, and clear out the lower bits we have already iterated over. Clear out the lower bits we've already iterated over, then check to see if, then exit if there is any bits set in the word. If not, advance to the next word and try again. Right, that's basically it. It's just a quick way of checking groups of bits to see if something is set or not. So get your word index into the bit set, relative bit index from the word. Get the clear mask just by shifting right and shifting left again, bit of magic, from a full-on set from every bit set. Get your word, clear the bits out, delete this because that's shadowing. We need to enable that shadowing that shadowing error in Clang because yeah, it's not good. We'll make it we'll make this a separate thing because I want to make it more explicit, you know. Right. If the word is empty, go to the next one. Bearing in mind, if you've gone out of bounds, like, because you haven't moved this. Wait a minute. You now need to advance the index. Also advance the index to word index. Oh my days. How are we going to do this? Hey there, not so red. How we doing? How we doing? Yeah, not doing bad, not doing bad. Just ran my favorite data structure, the object pool. We just finished up on the last couple of functions now. Doing a crazy iterator for it, but yeah, doing good. How's things going with you? You nearly finished school now? Like 20 days left or something, isn't it? OpenGL is just cut out some of the craft of OpenGL, right? But some of the render pass stuff, like DirectX 12 is now supports it, doesn't have subpasses. They decided to go, if you need subpasses, there's something the driver will be able to be better at. Because it knows the architecture. Yeah. I don't know. I haven't used Metal much, but Metal has like doesn't it have like a lower level tile memory thing, and you can use it. You can use tile memory and compute shaders as well. So it's really interesting. I finished already, but I haven't. But I have to do a project for them. Ah, okay. Not bad. What sort of project is it? They can't let me live my life. Yeah. Yeah, homework. Right, so if we ended up going to the next thing, we would have to increment. Yeah, see, again, remember I said this do while loop, I have to get rid of it? Guess what? Getting rid of it. Terrible. Do while loops are always bad. If word break. If not, advance this to the next. So we word index times 64. You know what? We only have to do this once, right? So you could say index, no, because you don't really care about index anymore. All you care about is word, isn't it? No, sorry, word index, which would be word index plus equal 1. And then you'd also advance the relative bit index, put that to 0 all the time. Oh yeah. And then you basically need to make sure if you iterate outside of the whole, like, iterate outside of the whole bit set entirely. So you're basically going to be saying like, okay, so you need to get the maximum number of words. So words capacity, which is the divided roundup of Where is it? That, basically. So if that is if word index is equal to that, then we return false, right? Because you've hit the end of the, you've gone and hit the end. Yeah, so that's obviously a lot more complicated than just iterating over each bit manually. But there we go. We check many bits in one time. So, yeah. So let's just double check this again quick. So you get your word index, get your relative bit index, get a clear mask, do a couple extra shifts. So the interesting thing about the clear mask is the clear mask can be brought out here again. Now the clear mask just becomes basically all bits on, right? You're not really clearing anything anymore, right? And then something like that. So that's a nice improvement. So words cap, clear mask. So you get the word, clear it. If it has any bits in there, awesome. We'll now get our index, and that's the next one we return out for the iterator. If it hasn't, we increment the word index. If we've reached the end of the bit set, we need to make sure that we output some maximum number, right? So we need to output like ID, or do we? Nah, no, we don't. We could like do something. We could pass. You know what? Let's be safe about it, just in case. I'll make it painfully bad. Let's set all bits on. No. Let's set it to the core null. Let's try that. Yeah. And we'll do a point of mu of null. Yeah, let's just be a bit safe about it. Right, so then you get your index by doing the word, what the current word is, plus the bit we've found in there that's on, from the least significant bit. Get the pointer, add the generation to it, bam. And then return out your ID and pointer, boom. There we go. So to do the previous version of that, I don't think it's too much, too different. So we can just take this and have a bit of fun. Web dev, ooh. Yeah, what sort of web dev do you end up doing at school at least? Is it like front end only, or do you do a bit of back end too, or both? And do you actually program? Because where I went, they didn't even care if you programmed or not. Use like a website generator tool thing. While I do feel DirectX 12 does like the extension thing a bit nicer than Vulkan, I still decided on a minimum feature set that is decently high, because I don't want to deal with the this GPU has this set of features you want. You still work around it. It still basically don't support the stuff that doesn't have the full minimum beat. You mostly care about PC, right? And the nicer are mainly a lot less of them, yeah. But then again, DirectX 12 are the benefit of being able to be more strict when it comes to stuff required. Yeah, they do have a big influence over the yeah. Yeah. Yeah, see, DirectX is nicer from the fact that it's designed around PCs and things. But yeah. Whereas Vulkan is more of like a committee-based thing, isn't it? But yeah. Yeah, these APIs are way too complicated though in general. It would be nice, you know, it maybe would be nice if we could explore a different reality where maybe like NVIDIA made an API and then AMD made an API, and we can sort of like see if that space is actually any better or just got as many problems as this one does. But yeah. Vulkan also has some negatives where we need to be extremely generic. Yeah, that's right. Yeah. So it's basically we went from a high level GPU API, sorry, high level graphics API to a high level GPU API to make a high level graphics API, and yeah, that's what we went to. Yeah, and a high level GPU API is not simple. Okay, so now I think we're in a good place. I really do like what we've got, but there is a problem, and that is with our free list. And I think we can make hopefully make this better. So I'm just going to quickly refill up my nice big glass of water, and then we're going to talk about this free list, why we have this free list in the object pool, what problem is it solving, and what problem is in the way. Glorious, sir, my friend. Oh yeah. Thank you so much there for the sub. Appreciate it. Welcome back. Thank you for the second sub. Appreciate it. I love a world where GPU. I'd love a world where GPUs don't have APIs. They have programmed like CPUs. Yeah, that'd be interesting, wouldn't it? They have like an ISA in some way, and like, but you got to remember GPU is a bit different, where it's got a shader cores, and then it's got some other bits and bobs around it. Um, so yeah, well, they would have to like they could start by giving us the shader cores, and then figure out how to give us the rest of it, right? Because GPUs basically like read a command buffer, and then they like give the work to the shader cores in an efficient way, right? So maybe they could give us a way to sort of like basically send command buffers in some sort of assembly way to it or whatever. I don't know. I mean, they could try and teach code, but they're slow. I mean, they tried to teach you code, but they're so slow. We've been trying to learn C for the whole first year, and we didn't even get to the memory stuff. Okay. Yeah. Well, technically, CPUs have their assembly as APIs, and the stuff in the background, like the driver, is out of order execution. Yeah, that's right, isn't it? Yep. Like, yeah. I was thinking that as I was saying the whole command buffer thing. Yeah. It's they basically have, yeah, they'll give us an API which is the assembly, or the way to sort of like poke memory and do something, and the system will react. Right, I'm just gonna get this drink, and then we'll do this, solve this problem. Put the icing on the cake. Right, I'll be right back. The water has been fetched. Oh yeah. Right, so a bit of a catch up with the chat, and then we'll carry on. Yeah, like it's really complicated how you start off with a do GP programming, right? First, you have to learn Vulkan just to do anything, and obviously you can use like OpenCL or whatever, but you're not programming directly against that chip. And even when you write a compiler for the GPU, which I've done, right, I've got the HCC compiler, you compile that to some high level assembly that you give to the driver, and the driver compiles that. And you only know that, and you can download the AMD compiler, which compiles SPIR-V into AMD RDNA 2 instruction set architecture, and you can learn that. But yeah, it's very removed from actually how you work, because you just get to see it, and I don't think you get to run it in a debugger. Maybe I'm wrong there. Maybe there are tools, but yeah, it's weird. Right. So with the object pool, it's basically just an array that allows us to allocate elements and deallocate elements from it, right? Okay. We've just written a super lovely iterate function which allows us to use the bit set to so we have a bit for every element basically, and it uses the bit set to figure out which one's a set. So it's better in terms of when you iterate over this if the elements are kind of next to each other, because then you can just read the bit set for all the empty spaces, and there's less memory to traverse than iterating over all of this and you know, reading these elements and whatever. So there's that. Oh yeah, and if you have the elements that are next to each other, you've hopefully read very similar caches, maybe, depending on the size of these elements. You know, that maybe doesn't matter because these elements could be quite large. But anyway. Yeah, so maybe that's not too bad of a problem, because you could just be reading an element anyway. And if there's holes in it, it doesn't really matter because your element's probably like, I don't know, maybe. Okay, so the problem with this free list, so the benefit of the free list is this, is when we allocate, it's super quick, right? So rather than having to iterate over the whole bit set to try and find a free element, which could be quite bad because we could have, you know, these empty slots could all be filled and it'd be quite at the other end of the array before you'll find your slot, and you don't know. So the easiest way to solve it is like, right, we're gonna have in the object pool a free list head pointer, and this just points to the top of, you know, the head of the free list, and if that's set, we can basically get the index by doing a bit of magic where we take the differences between the pointers and divide by the entry size. Gets us the index, and then we can why did we add again? What a complete scrub way of doing it. We already have the pointer, folks. There we go. Anyway, and then what we do is we dereference the we you know, we've stored the next pointer, at this. So we've got a pointer to this element that is free. This is the free list head, but this one points to this one, and we simply just store the pointer to that in here, and we fish that out, and then that becomes the new head, right? When we allocate an object, okay? Then when we free the object, we simply, or when we deallocate some object, we simply just store the current free list head in there, then we become the new head, right? That is it. There's a problem though with this code. Why do you not have a ring buffer for the pool where you can use deterministic pre-allocated pool size? How would a ring buffer help? Where does my data go over the edge and come back around again? Where does it do that? Use a deterministic pre-allocated pool size. But we pre-allocate, we only allocate the pool once, right? Oh, graphical debuggers. Yeah, that's with RenderDoc though, but that's not on the assembly though, is it? But yeah, with RenderDoc you can do it. Yeah, but I was talking about more of like the assembly stuff. Yeah, it's not really instruction by instruction though. It's spear v and spear v IR, right? Not for member only, but for the object pool. So what you're saying is like you would allocate in a ring buffer fashion. But yeah, I don't know if we'll free in the order that we allocate though, right? You know? Yeah, I think I see what you're saying. But the issue is if you do the ring buffer, is you have to kind of free in the same sort of order. Or maybe, yeah, it's interesting though. It can definitely solve certain issues though. Right. So the problem is with allocate at. The problem is with allocate at is that we tell it this is the one we want to allocate. Then we get the pointer and we just zero it. Well, guess what? It's got the free list of information in there. So really what we need to do is we need to patch the free list. So in order to do that, we kind of need like a linked list that points to the previous and the next. So we need 2 pointers. So you know what? Let's make that change. And I think that's what we'll do to fix it. Just use 2 pointers, which is not. So it has to be at least 16 in size. You know what? We could just max it with 16, and then it saves the assertion, right? Why don't we just do that? No. Times 2. Must reduce the size of 2 pointers. Have a free list in its place. When you do an allocate, so when you, so we could have the structure. Core object pool call it a free entry or something like that. So I have like a next pointer. I gotta clean up some of this code actually, I just realized. Previous and then next pointer. Excellent. So I think we'll be using this instead. Okay. So what we'll do is when we allocate and we do the double pointer cast, what we're going to be doing is actually so you would say is equal to free entry next. Yep. Then when you allocate at, you've got to get your free entry. You've then got to patch. You've got to make the, if there's a previous, oh, we didn't, yeah. If the free entry has a previous, we make it point to the next. So you say previous free entry. So it's just a something like that, isn't it? So you'll make the previous point to the next. Free entry next. And then you make the next point to the point to the previous, right? So if that something like that. And then when you do your deallocate, I have to double check this in a sec. When you do your deallocate, you'll say free entry next is equal to the object pool next and previous is null. But then you have to make sure that the one at the current free list entry or whatever. Okay, I think this structure is going to be more public because then we can use it for this. It's kind of an internal thing though, to be honest. Yeah, let's not do that. This free list head. Did we change the free list head for? So when you deallocate, the free list head has to point to point back. Hey then, program bro. Yeah, it's doing good, man. Doing good. Just write me a super fancy object pool. How's things going? Double-ended circular list if you're in a ring buffer. Perry! How's it going, Perry? How you been? How's things going? It's my Friday today, Perry. I'm on holiday tomorrow. So you're on your free free list previous to point to the current pointer. Right, so you point to the free list head, then it points back to you, and then you become the new free list head. Right? Excellent. So that's how you get the previous thing to be set. Alright, let's just double check this is all decent. So when you allocate, all you care about is you get your pointer. Okay. Your free entry. Wait a minute. Yeah, you get the one that you're allocating. And it will be the head, right? So I guess you could do an assert here. We want to say like entry is not the free list head, right? Or we said the free list head shouldn't point to a previous free entry. So we're going to say that is equal to null. So then yeah, that just becomes the new free. Yep. Oh, then you should take this head, and what you should do is you should say, should you clear out the yeah, you need to clear out the previous. You need to say free entry previous equal null, right? Your next in line. Excellent. So that will be that one all sorted out. Then when you allocate app, you're going to say, hey, I want to allocate this element. We check to make sure that's all okay. Then what we do is we get you the pointer to that. We turn it into a free entry. If there's a previous, we make the previous point to the next. If there's a next, we make the next point to the previous, so we can eliminate this one. So imagine if we were to draw this. You've got 3 entries, okay, that point to each other. This one points to that one, right? This one points to that one. This one points to that one. And this one points to that one. Do a couple of next and frees, okay? So all you're doing when you allocate this one. So when you allocate this one, all you're doing is you're making this one point to this one, and this one point back to that one. That's all we're doing with this code. Not too much rocket science. Cool. So that will sort out the free list. All right, that's the object pool done. So we can take it for a spin. Then we could do a little bit of a cleanup or something. So I've got to quickly sort these core defines everywhere. So should we do a nice grep? Oh. Oh, I can't jump. I need to get better at this. So it's in GPU. Okay, we'll do that. GPU. Core define ID. Oh yeah. Right, back compiling now. So let's write some nice little test code. Let's test out these super lovely object pools. Good mate, how are you? Is Mum enjoying the first week of leave? She is, Perry. She woke up the other day, and when she woke up, she was just sort of rolled over and it was just like, "This is the life," you know. So she's been enjoying. She's been enjoying the leave. Yeah, just she's been going swimming. She's also been running some errands, but also just sitting down on the sofa and got her feet up and watching some films. She's enjoying all that. Exactly, that's it. This is the life, and then like baby comes. Yeah, I'm sure she's gonna enjoy it a lot. Um. See, part of me wants to like. Part of me really wants to allow it so I can put a semicolon here. You know what I mean? But I can't. What's something I can do that can just linger in code? Like, cause me to just put. Can we define like an empty enum? Is that legal? Oh no. I want to just like put something here. Something. Stack assert true. just do that. Alright. That's what we're doing in the place of it. I can't figure it out. I just want some dummy there so I can put a semicolon at the end. The enum needs a name. Yeah. No, the enums don't need a name. But yeah, they need something in them apparently. Yeah, I booked a holiday, so I got like tomorrow off. So yeah, it's gonna be good. Would you ever write a book? Clean code. Who's he? Nah, that word has been tainted. You know, it's been tainted. There we go. Put the semicolon there now. Look at that. Amazing. Right, so let's define ourselves an object pool and have a bit of a play. So imagine if we have an entity. Right, so a nice core define ID. Get ourselves an entity ID. And then we're also going to define ourselves an entity data structure. Isn't it going to be amazing? Then we just give it a name. Two weeks off in August, book 2 days in September to play Starfield. Oh yeah. Cool. Yeah, I got like a whole month coming up off work soon, so that'd be amazing. Because the baby's coming, so I get to like figure the thing out. And then we're hoping to go to Australia at the end of the year. I'm trying to book some tickets for that, but I'm gonna, we're gonna also have the baby with us as well, so we're gonna try and figure out some passports for that, you know. Yeah, paternity leave. Oh yeah, yeah. So I get 2 weeks from the government and then 2 weeks additional from work, so I get a whole month. So it's pretty nice. Yeah, taking the baby on the plane. Yeah. Very intelligent ideas, as you can tell, Perry. Very intelligent individual. Yeah, it's gonna be interesting. It might turn out really well, but we don't know. We'll figure out. Right, so like we've done in the past, right? We've got this allocate here with 4 megabytes. We've got these integers, and we pushed on some things. We did some removes of things, and we've printed them out. Then we did a hash table, and we did some inserts, and then we did some removes. Right now, it's time to do the object pool. Oh, I don't have an object pool thing. We need a thing, guys. So object pool T. Hold on a second. If I was to ever have a kid, would that still be called paternity for me? I have no idea. Too much mental gymnastics. Just make sure you phone the airline. They'll get you one of the seats with a cot. Yeah, that's the thing. It's like maybe we can book the tickets before, then give them a phone call afterwards. I have no idea. We're gonna have to figure this one out. Because I think we need like a passport for the baby, right? And the baby's not born yet. But we're hoping to try and get some tickets cheaper. So kind of want to order them earlier, you know? So here's our object pool. Oh yeah. There it is. Nothing called object pool entity? What is wrong? Oh yeah, now we've got an object pool. So, how does this work? So we simply just initialize it. Address to the object pool, please. Then we kind of want to say, here's a allocator you can use to give us some of those memories. Those sweet, sweet memories. And then we say we've got 128 little elements in there. And now we don't have enough arguments for some reason. So let's have a look at that. Alright, there's too many. Get out of there. Get out of there. Alright. Now we're in business. So, now next thing we want to do is actually so we allocate some entity. And we're going to say, call it A. You know, there's too many A's, B's, and C's, so let's give this a little bit of a shift. So we're going to say A is going to be equal to core object pool allocate. So just say allocate entity for me, please. Give it the entity object pool. And we basically just need an ID out. Oh yeah, this is what we wanted to do. We maybe don't want all of the... Oh, we get to use the iterator. This is going to be amazing. Maybe you don't want the ID to come out, so we'll just be a bit nice to you, right? There we can below if statement. Anyway, so we'll pass. We'll get the ID. Entity ID. AID. AID. When I flew with or to Australia, there was multiple seats with cots on the walls. Yeah, I remember seeing some of those before. Not sure about the passport though. I thought they'd have to travel on yours underage. I think they have to have their own passport nowadays for some reason. It's not like. Is it paternity leave one of those questions that's only confusing for trans people? Well, no, it's confusing for everyone, isn't it? Like, if you're trying to give it to a trans person, what is that? Yeah. I guess it just relates to like how much time you need off, right? Because, you know, is it like a natural birth or are you getting, there's tons of questions, right? I guess it has to be applicable to like what is the thing you're doing. Yep, you need a passport for the baby and documentation attached to the mom's passport. So stops kidnappers, right? Yeah. So I need to figure out like, do we need that when we buy the ticket, basically? So I get that sorted out. It's risky to have a newborn travel on the plane. The eardrums are very, very sensitive for pressurization. Yeah, so it's gonna be like 6 months old by the time we travel. So it's hopefully better. What is better? One big heap/block, or many smaller blocks if you want to do lots of writes to it. I don't know. It entirely depends on your problem, right? The problem you're solving with the allocator, right? Um, what? Did we do a silly? We did a silly. Boom. Right, there we go. So it's not, another reason why we're testing out is so we can make sure we find those little issues. So we allocate an entity, it should be zeroed memory. We're then going to say, okay, name is equal to good old Jeff. And then we need, we need a Perry, don't we? Let's do Perry. And then we'll have Jeff. Now, we're then going to also have we also need a Don, right? Need a Don. And who else do we need? Also have Mr. John Mega as well. There we go. We've got a Joe Mega in there. No, Glass hasn't been here today. Right, so what we want to do is want to try out our super lovely iterator. Right, so we've got an object pull iterate next. Okay. So the idea is we want to say like entity ID, just call it ID. Right, very, very creative individual I am. Then we want the object pull. We want the address of the ID. Then I want obviously the pointer to the entity that we're looking at, so we'll call it entity. Now bear in mind you have to start it off at 0. If you don't, it doesn't work. So you do like your core null, ID null or something like that. Entity ID, something like that. There we go. And then you just do that as null, right? Ta-da! So we're just going to say, hey, we've found one of those entities. and it's got a name. Have you seen this? What is that? Let's have a look. Don Ho class on my days. Oh, this is great. This is great. That's amazing. Has Glass seen it yet? That's legendary. Alright, this is test number 1. The next test, I guess, is we'll deallocate all the objects. And then maybe allocate some more. And try the old handles out. See if they crash, maybe. Oh. What is going on? Error passing, you know, it's for a proper compiler. Oh. Address of void object pool. Right, so just the safe cast. There we go. Now let's give it a nice little run. Entry must be at least the size of 2 pointers. So we got a free list, blah, 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 blah. So, okay, 2 pointers. Perry, this iterator loves you. Look at it. Perry all the way. Endless Perry on my screen. Where's Don's Discord back? Has he got Discord now? I need to join this. In the bathroom and it turned into a meme. That's great. That's cool. Yeah, I remember you said it was Discord. That's good times. Good times. I need to join that again. So the iterator is obviously buggered. Buggered. So with ID Lee. Okay. So here we're going to put a nice breakpoint in so we can really see what is going on when we go next. Because that's where the issue is, right? It's the times after. No. Let's just put it here. Let's see how the first one reacts. Let's do a nice GF, hop in there. So you get a 0 index. You have a little bit of a look. What you discover is there's a bit waiting for you. That's 0. Good. Just take it. Let's roll. So then that's a Perry right there. Then we've finished with Perry, and we should. Why is my ID is 0 still? That's not right. Oh shoot, we set it to ID and not index. Rookie. Hmm. Wait a minute. Alright, let's try that. Wait, we need to put the breakpoint down here so we can actually see before it just runs the game. Right, there we go. It's got Perry, Jeff, and Don, and then Joe Mega. Excellent. So let's put a hole in here. Right, so let's get rid of Jeff. Jeff's not wanted anymore. Core object pool deallocate. So we deallocate Jeff, which is CID. No, that's Don. Oops. So goodbye to Jeff. Let's just make sure we don't print out Jeff still. Oh. Seg fault. We didn't check if the free list is set or not. Rookie. Let's try that out. So then we removed Jeff, and now we've only got Perry, Don, and Joe Mega right there. Look at that. Isn't that amazing? So 6, 7, 8. Oh, 6, 8, 7, nice. One thing that's kind of stupid in Graphs APIs is why is there a separation between winding and culling mode? When you write it, I just answered my question as the depth stencil can depend on the, can also be dependent on the winding order. Right. Yep. Okay. Ooh. So that was decent. Now let's reallocate. Let's have a bit of a play, right? Let's say right IDX, and then we'll do a generation in there as well. So we'll do a very simple proof that this works. So we'll AND this with the mask, core object pool index mask, and then we'll do like an ID dot raw shift right core object pool generation shift, right? So see they've got a generation of 1, then it's 0, 2, then 3 because Jeff was 1, right? Now if we bring back one of these guys in, all right, we'll bring back B in again, and then we'll say this one is equal to like I don't know. Who we got? Who we got? Let's do not so red. Maybe it's still there. Yeah. Well, that is a seg fault apparently. It's a good little test. He is. Well, you've got a little entity for you now. Right. So the free list head again. Okay, so using that free list head now. Really, we should delete a few things. Right, let's get an E in there. And make that VMT. There we go. Right, so I think if we deallocate a couple of things. Right, let's get rid of Don. There we go, Don's going as well. We want to make that free list. I want to test a bit of that free list code out. Alloc void. There we go. So we don't want to mess with this unless it's got something already. All right. We got null. No. Oh, wait. What happened? What happened? Right, so we've got Perry Not So Red, Joe Omega, and VMT right there. That's good, that's good. We don't delete Generation 2, Index 2. Right, so that reused C. Right, 0, 1, 2, which was Don. Reuse that one. Excellent. So we delete Don. But obviously we reuse 1, because that's just a free list, right? Yeah. Oh yeah. Oh, so you can actually look on Twitter now. Interesting. Without an account. Hmm. Yeah. That didn't really affect me too much anyway. But I could see how it could be annoying for people who share lots of stuff with people. Okay. I think I'm pretty happy with this now. We could do more testing. Right. But I think... Oh, the iterate previous is buggered. I just realized. We didn't even... Actually, did we even start doing anything with it? Because I just copied and pasted it and then I went to get a drink, didn't I? What did I do? Yeah, I think I started doing something with it and I didn't. Right. So if you have a null one, your index becomes... Yeah, I went to go and get a drink, that was it. Cap, take 1. Right? And then... If not, you did an index -1. But if your index is equal to 0, you return false. Right? Because you've iterated over all of that. Nice. The take 1 could really just be put here, I guess. Anyway. Now, what we did it the other way instead now with a clear mask? You want the high bits removed, right? So if you want the high bits removed, it's shift left then shift right. So you want the high bits removed, and then you want to... Right, and then you put the word back. Then rather than do the least significant bit, you do most significant bit index. Yeah, that's it. That'll do it. So we can test that out, right? So here we go. Let's do a previous search. And it's going to be the inverse, right? Again, we found. Ooh, this one buggered. Oh. No, we'll look at that one. Let's move the breakpoint. Alright, let's investigate this one. So this is going to go from the end of the pool, which is like 128 or something. Yeah. So land in word 1, relative of 63. Right. Get the clear mask. Shoot, what are we doing? Why is it 63? Right, because we've just looked at 60. Clear the bottom bit. This is wrong. This is clearly wrong. Um... So I think you might want to do like 64 take. So we did index -1 here. We could have just left it on cap, to be honest. So if you got 63, you kind of want to leave all the bits on, right? So are you just in a one shift left the number? Yeah, that's what you're doing, isn't it? One shift left. Something like that. Let's have a look. Because one shift left. I'm going to take 1 or something like that. So you want to have a clear mask. So you probably want to do like a rel index +1, one shift left, -1. So no, that won't quite work because you'll overflow, won't you? So if you got 63, you want all bits on. If you got 62, you want all but the last one on. So basically, you want to do like this sort of shifty trick, where you want to do this shifty trick, where what you're saying is index +1. You know, yeah. So we'll say like 64 take index +1. Modded with that. So that'll put you onto, that give you 0. Is that right? Oh, no. The +1's too early. Yes, I give you like 63, add 1, 64. Yeah, perfect. I think that's what we want. Oh, we hit the... Still bugging it up. Alright, let's have a look. Where are we going? Into the previous, iterate previous, right? So relative index of 0. So you're shifting 0. That's right. So we've got a full-on clear mask. That's good. So it doesn't clear anything. Then we look at the words. We have nothing in there. So we go back by 1 because we're going from the back and we've only filled in the first 4 bits or whatever it is, right? So we go back. We get the... Have we... Oh, it's already if you reach capacity. It's if you've reached 0, isn't it? Oh, so we could... This could be a problem. Well, it is a problem, but yeah, this could be the only problem maybe is C. So if you're on 0, bail. Hopefully this is it. You ready? No, it just keeps going. Okay, we'll try it again. Alright, let's have a look. So the first, this seemed fine. Then you set the relative bit index to 0. Okay. Clear mask. Do you need a relative... This doesn't even need to change, does it? It's relative bit thing. So really that could be an optimization we sort out. Clear mask is all bits on. Nice. 29. Excellent. Then you break. You should do a most set bit. So which one is that? 37. Is that true? 29. Oh, my bit MSB is buggered. We'll investigate that. Right, let's clear out that. Because I need to mutate that thing, you see. Okay. So I think this bit MSB is buggered. What is the least significant bit one? Trailing zeros, leading zeros. I don't know. Have a think about it. Yeah, GF. It's a front end to GDB. It's pretty good. I don't know if that's right or wrong. Well, it definitely gives us the wrong result. So I think, should we break it into 2 parts? Let's try this just for the debugging purposes, right? Oh, you bugger. Mess that one up. Okay, so here when we do this MSB thing, 27. So that's So if we do p slash x v 1d. So right, I have to view this in the. I'm not that pro at that. So let's just have a look. Wait, when's the one? Oh, we didn't do CLZ for a long. We did CLZ for a short, for a 32-bit integer. Yeah, you bugger. So CLZL. There we go. CLZL for long. Thank you, thank you, thank you. Appreciate it. Welcome to the sub tier. Thank you. Thank you, Barbero using. Appreciate it. Welcome, welcome. No worries, no worries. I'm just doing what I'll be doing anyway. So just sharing it with the world. But yeah, if people are interested in getting access to the code, you can sub on Twitch, or you can support via Ko-Fi and send a little bit more of the money towards me. There's all the information is on the Discord there. You can also join the Discord and come and hang around and chat about this project or just programming in general, really. But yeah, thank you so much for the sub there. Appreciate it. Right, it's the CLZ0 long, of course. So we're gonna fix that up in HMaths as well. For HCC, we'll sort that out. But yeah, interesting. So that hopefully fixes it. Right, one more thing. So that's 20. Yeah, maybe it's still wrong. We'll think about it. Just investigate that number a little bit more. Alright, go over one loop, hit the lower bits. Right, so the number we get back is 5. Is that right? So we allocate like 6 objects or whatever. I think that's right, isn't it? So maybe it's like when it hits the. I think it prints out fine. Because if we take a look outside, entity.name. Oh, it's a null pointer. Grr. So clearly that was wrong. 0, 1, 2, 3, 4, and deallocate 5. So it could be off by 1 somehow. Is it that most significant bit thing that's wrong? And we don't know, do we? We could try it again though. So if you look at the word, that word index time will just be 0. Right, oh, okay, it'll just be 0. Yeah, so whatever the result is the result from that. So the word we have is 1D, which was 29. Yeah, so we threw that in the calculator, didn't we? So we have bit 5. That's 4. Right, so this bit MSB thing is off by 1. Classic. So if you're doing size of, what we should be doing is size of take 1. Right, this one's even more. So we did I think we need to do 17 on that one. Okay, that should be the fix we're looking for. Alright, of course we hit the breakpoint. Let's remove that. Oh yeah, here it is, right. That worked. So we did this one with the forward loop, then we did this one with the reverse loop. So we, it was Perry, then Not So Red, then J Omega, then VMT. Then for the reverse loop, it was VMT, J Omega, Not So Red, then Perry. Excellent. We did it. Yeah, bugs and bugs and bugs. So we've got to make sure we actually send that up to the HCC project, which is our custom C compiler for shader programming, but it also has a little maths library in there as well. So it was specifically in HMaths, wasn't it? Oh boy. So we need to go into third-party HCC HMaths. It was in the HMaths, obviously. It's the only file. We want to put that in this one. This is old. Fool. This is the new one. Excellent. Overwrite that. Then we go into the repo. So it'll be HCC. Then it is a submodule, right? Good and bad things about submodules. Also lots of good and bad things about Git in general. So we want to say like, fix bit MSB, CPU, CPU Linux implementation. Let's push that up to the GitHubs. And then we CD back into here, do a little git status. We find is that this one has more commits. And, update the page maps. And there we go. So now the HCC repo has been amended. All the little fixes we've just done. Cool. Radio. So what is next on the agenda? Yeah, so I think I'm pretty happy with that now. I think the object pool is in a good place. Obviously, there is probably more bugs, but for now, this is good enough testing. We'll just fix it as we go. So we can allocate, deallocate, and iterate through the stuff that we have, which is cool. Right, so the next thing to do is I want to quickly have a little tidy pass and respect the code base. So we actually have a core internal. Oh, we don't. Let's pragma once on this one, please. Then we'll do a nice little core. See as well. So I want to include that in there. Include the internal for me, please. So we've got a few things in here that are kind of they're sort of privately, like that only to do this internal thing, but I like to forward declare them in a header so you can sort of see all of them. So there's a few things. That one. Don't worry, you'll be sorted out. Some hash stuff. Right, hash table. Number of bucket entries, chuck that in there as well. Oh, this enum. Little special enum for special hash table hashes, so empty and the tombstone hash. What else? Right, this object pool has a super lovely free entry thing, but it might have some more things. It needs one of these. Object pool is initialized, right? So I wanna, right. So I need to dot that in every one of those functions, and I need this little lovely macro. Object pool, and then we just want to say object pool entries. Not equal to null, please. No, there we go. So I mean it's initialized. Yeah, so I want to chuck this in everything except for the initialize, like just right at the top. I'll catch some problems there. So drop that in there you go. Any other little assertions that we might be missing? Let's have a look. The capacity in that should be null, right? So did we do like a non-zero thing or something like that, wasn't it? Yeah, we did non-zeros before. Yeah, capacity non-zero, please. Oh, I use okay. Entry size. We're fine with that. ID. We've already got the. Let's move it up. Let's get it a bit in the way. Like there is the. Yeah, that's optional, isn't it? It's fine. Just keep going. ID. This one has to be set, but it can't be null, right? Yes. Cool. When you deallocate, this can't be null either, right? Then iterate. These are all fine. Excellent. Excellent. Loving it. Right, so let's just recompile that quick. There we go. Still runs. Okay. So now we're in a really good place. We've now finished all of the collections that we'll ever want when we R&D, pretty much. So okay, let's get this stuff committed, and while we're committing, we'll talk about the future. So the next feature we need to actually work on is the next feature that we actually need to work on is keyboard support and mouse support and gamepad support. But what I want to so add object pool. Let's do that. Let's do a git Still need to do this silly dance. And then we'll push that up to the origins. Then we'll tag day 13. Check that up. Come on. Day 13. Chuck the tag up, please. Push origin tags. Right, so for those who have access to the code, you can go and get the latest and have a play with the object pool that we've got up there now. When I'm finished with the stream, I'll check if it still runs, if it actually runs on Windows or not, because it could fail on Windows, right? So I'll give that a test in a bit. So yeah, so the next feature we have to actually implement is like keyboard support, but I think what I want to do is go around the code base that we have right now before we create more mess. And I really want to test out the collections that we have and the custom allocator thing. And just have a sort of a, like, just use the custom allocators where possible. Like set that up, set up like the stacks and the hash tables and object pools. Like we'll probably have one allocator for like static data that we use, and then we'll have one for runtime. And that's what we'll probably roll for to begin with. Gotta go, it's 3 in the morning. Enjoy, everyone. Okay, thank you. Thank you for coming, and have a good night. Yeah, and then after next stream we'll start that we'll start the keyboard input and the gamepad input on Linux, and then we'll do a Windows version, which would be super cool. Okay. So just a quick visual. Right, there's not too many places in the code. Maybe we might get a start on the keyboard stuff next stream, it depends. But there's like stuff like this, right? These 32 arrays of 32 or whatever, and this could just be a dynamic array. Or something like this. This is an object pool here, right? Just take for the code and really just address all those issues. But yeah, it's going to be awesome. Right, so there's a Discord right here. And there's a Twitter right here you can follow me on. Let's find somebody to raid. Oh, Raymarch is streaming, eh? He just started. Let's give Raymarch a raid. He pops in the chat sometimes. He's working on his little shame compiler thingamabob. Yeah, have a good night too, not so red. I'm gonna get a nice sleep, and I've got a day off tomorrow, so it's gonna be good. Have a good workout tomorrow, you know. You creating a Google account with a username. They cancelled it. Ah. Ouch. Can you recreate it maybe? I would have, Perry. Thank you so much. Appreciate it. Right. Have a good weekend, everyone. I'll see you all on Sunday. There is definitely a Sunday stream this weekend. I promise. I've had to cancel the past couple. Oh, that'd be cool, Jim Oga. Awesome. Right. See you all Sunday, hopefully. If not, in a future one. See you later, guys. Bye.